Hi everyone! Today we are going to learn the last section of Chapter 12, which is also the last section of geometry for this year. So 12.5 is find probabilities of independent and dependent events. If you look at this paragraph down here, it tells us that two events are independent events if the occurrence of one event does not affect the occurrence of the other. And two events are dependent if the occurrence of one event does affect the occurrence of the other. So now we have two equations for independent and dependent event and finding the probabilities of those. So for independent events, if you're trying to find the probability of A and B, you are just going to multiply the two probabilities together. So the probability of A times the probability of B. For dependent events, to find the probability of A and B, you're going to also multiply. However, you're going to multiply the probability of event A and the probability of event B occurring, knowing that event A has also occurred. So here's our first example. We're going to talk about independent events. As part of a board game, you need to spin the spinner at the right, which is divided into equal parts. Find the probability that you get a 25 on your first spin and a 50 on your second spin. So we're going to say that event A is the first spin lands on 25. So if we look at our spinner, we notice that there are two 25 pieces here, and there's a total of 8 spots. So the probability of landing on a 25 then would be 2 out of 8. Event B, the second spin lands on 50. So let's look here, and I only have 150, so that probability is 1 out of 8. Now these are independent events because they don't depend on each other. There's an equal chance of landing on any of these spots since they are equal size. So I'm going to just multiply my two probabilities together. So 2 over 8 times 1/8. That's going to equal 2 over 64. So I would accept that as an answer. Or if you want to simplify this, 1 over 32 is also an answer. Now we're going to move on to dependent events. A bowl contains 36 green grapes and 14 purple grapes. You randomly choose a grape, eat it, and randomly choose another grape. Find the probability that both events A and B will occur. So we see that this is dependent here because we are going to grab a grape, see what color it is, and then eat it. So that means that the probability is going to depend on what the first grape was. So event A is going to be the first grape is green. All right, so we know that there are 36 green grapes, and there's a total of 36 plus 14 grapes, which if you do that math, there's a total of 50 grapes. So the probability of choosing a green grape then is going to be 36 out of 50. So we grab a grape, it's green, and we eat it. So how many grapes now are left in the bowl? Well, if we take away 1 from 50, we then have 49. And then it tells us here for event B, the second grape is also green. All right, well, if there were 36 green grapes, we ate one of them. That means that there's only 35 green grapes left. So now with this new probability, I'm going to multiply these two fractions together. So 36 divided by 50 times the probability of event B occurring, knowing A has already occurred. That was 35 divided by 49. All right, so that is 1,260 divided by 2,450. This can also simplify, but I'm just going to keep it like this for right now. Conditional probability. You can also rewrite the formula for dependent events from the first page of this lesson to give a rule for finding conditional probabilities. So this is just another formula if you're trying to find the probability of B given A. Alright, here's our last example, selecting cards. You randomly select 2 cards from a standard deck of 52 cards. What is the probability that the first card is not a heart and the second card is a heart? If A, you replace the first card before selecting the second, and B, you do not replace the first card. If we do replace the card, that means that we're going to have independent events. So all we need to do is find the probability of event A and the probability of event B. So A was the first card is not a heart. So we know in a standard deck there are 13 hearts. So if it's not a heart, 52 minus 13 is then going to give us 39 divided by 52. And event B is that the second card is a heart. And like I said, there are 13 hearts out of a total of 52 cards. So when you plug this in your calculator, you then get 3/16. For part B, you do not replace the first card, so these are dependent events. The probability of event B occurring depends on did A occur or not. So we already know that the probability of event A occurring is 39 out of 52. So now I took that card and I placed it to the side. So how many cards are left? 51 cards. Well, how many hearts are there? There are 13. So I'm just going to multiply those two fractions together, and I get 13/68. And that's my answer, and I'm done.